Alright guys, so we're going to do a little video tutorial over beginning mole conversions. So a couple things to have in front of you. One, of course, like always, your handy periodic table. Two, calculator. Alright, and I'm going to refer to our little flow chart here, although you guys remember your goal over the course of the next week or so is to try to ease yourself off needing to use this. This is a great reference to begin, just for practice, but over time we want to get ourselves away from this and just kind of know what to do. Okay, so keep that in mind, but I will be referring to this just for this particular tutorial. All right, and our focus questions are going to be number 4, 6, and 10 from the last page of ChemQuest 26. Okay, so we're going to go ahead and begin. So we're going to do number 4 first. It says, what is the mass of 3.45 moles of aluminum sulfate? So before we go in and tackle that problem, the pre-work we got to do here first is we got to write our formula for aluminum sulfate. And the reason we need to know that is because I see the word mass here, which tells me I'm going to have to try to figure out my molar mass. All right. So find my blue marker, please. All right. So number 4. We are trying to find the mass of 3.45 moles of aluminum sulfate. So I'm going to start by writing my formula. Aluminum I know is +3, sulfates are -2, right? That ATE tells me it's from the back side where we put that polyatomic ion sheet, right? So my formula is going to be Al2, right? And then SO4, 3, right? So now I know my formula. Second thing to do then is to figure out my molar mass. Now notice I'm not even starting my conversion yet. I see the word mass in my problem, right? That means I need to know my molar mass, which means I also need to know my formula for the compound, okay? So we've got Al2SO43. So to figure out that formula, right, I'm going to have to go 2 times the mass of aluminum. Okay, so that's because we have 2 aluminum atoms there, so 2 times the mass of aluminum. Where do you find the mass of aluminum? On the periodic table. That's the number underneath the Al symbol on the periodic table. Next, I have sulfur and oxygen, right? The 3 is outside the parentheses, which means it applies to everything inside. So that means I'm going to have to take 3 times sulfur. I have 1 sulfur inside, so 3 sulfurs, so plus 3 times the mass of sulfur, which is 32.07, plus, okay, now, again, going back to my formula, I've got 4 oxygens inside, and I have 3 outside, which means I'm going to multiply that value, so it's going to be the mass of oxygen times 12. All right, so plug numbers into my calculator, and when I do that I get a mass of 342.17 grams per mole. All right, so now that is 1 mole of aluminum sulfate, right? That's what molar mass means. That's the mass in grams of a single mole of whatever compound we're looking at, right? So this is aluminum sulfate. That's the mass of 1 mole. Now, the question is, what's the mass of 3.45 moles? All right. So to set this problem up, just showing my units. Now, some of you guys already know. Oh, I just multiply. That's easy. You're right. It is easy, but we're going to keep track of units just for good measure. Okay. So I have 3.45 moles of aluminum sulfate, right? Then in a fraction over 1, right? Moles goes bottom, grams goes top. Now, I know I want grams in my answer because I'm asking, what is the mass? So this is a moles to grams question, right? Now, lots of you guys, again, you've already figured out the need to multiply, but let's just verify that with our little flow chart here, right? So my given quantity, 3.45 moles, that means I'm starting right here in the center of my flow chart, right? And in this case, I want to know mass. grams is a measure of mass. I'm going to go from moles to grams, which means I'm multiplying by the molar mass. Okay, it's that simple. So I'm going to go ahead and just plug those numbers up there and keep track of units. Grams goes top because that's the unit I want in my answer. I'm going to here. Okay, so in 1 mole, there are 342.17 grams. All right, now I'm not writing the aluminum sulfate in there. I'm going to put it in my answer. All right, I'm just trying to kind of save some space so I can write large enough for you guys to see. All right, but this is 3.45 moles of aluminum sulfate, so I will be sure to put that in my answer. All right, now I get to kill my moles there so that I end up with grams in my answer, and when I multiply that out, I should get 1.18 times 10 to the third, or 1,180, however you want to do that, grams of aluminum sulfate. There's my answer. All right, so again, I'm going to walk you guys back through the logic here. It says, what is the mass of this many moles of aluminum sulfate? First I had to write, I see the word mass, that means I need my formula because I have to figure out my molar mass, right? That is how I interchange between moles and mass. I need to know molar mass, right? So I wrote my formula first, Al2SO43. I found the molar mass by adding all the different atoms with their masses together, all right? Once I need my molar mass, I can then just plug numbers in to do my conversion, right? I started with moles, right? Which means on my flow chart, I'm starting in the center. I needed mass, which is grams, okay? So going from moles to grams, so I'm following this arrow out, so that means I multiply by the molar mass, which is what I did here. There's my answer. All right. So moving on to number 6, right? So it says that I have 245 grams of lithium carbonate. How many moles is this? Okay. All right. So I'm starting with grams. I see moles. Now, grams is a mass measure, right? Which again means I am going to have to use my molar mass in a conversion. Which also means I need to know the formula of lithium carbonate. So lithium, I happen to know is a +1. Carbonate, I happen to know is a -2. And my pen is running low there, so I'm going to go back to my blue marker here. Lithium +1, carbonate -2, which means my formula here will be Li2, and then just CO3, 1 carbonate there. All right, so there's my formula. All right, so I find the molar mass of lithium carbonate, which is going to be 2 times 6.94 plus 12.01 to have just 1 carbon there, plus 3 times 16.00, right? And just looking at my pre-work that I did here, I get 73.89 grams per mole, right? So again, I'm just going to box that in. That is my molar, mass, right? So that's a number that I have to use in my conversion. Okay, so going from grams in this case to moles. So I'm going to go back to our handy road map here, right? So I'm starting in grams, right? I'm going 2 moles, which means this time I'm going to not multiply, I'm going to divide. But I'm going to use that same value, that molar mass that we just calculated. So this time, rather than multiplying by the molar mass, because I'm going this way, I will divide by the molar mass. And we'll show how that works with units, right? So I have 245 grams. One, right? Grams goes bottom, moles goes top this time. So it's just the inverse of how we did it last time, right? So in 1 mole, how many grams do I have? That's my molar mass. 73.89. And when I do my division, I should get 3.32 moles. In my answer, I'm going to put lithium carbonate. Okay, you can cross out my grams there too, because that's fun. So again, this time I started with grams and I wanted to go to moles. I still, every time I see grams or mass, right, every single time I need to make my conversion or figure out my molar mass to make that conversion. All right, so every time we see grams or mass, we know we need to calculate the molar mass. Okay, so I calculated that first, which means I needed to do my formula first, right? So that was 73.89 grams, that's my molar mass, right? So then I used my flow chart. Really, I got this in my head now, but you guys will soon. Going from grams to moles, which means I divide by the molar mass. Shown right here, 245 divided by 73.89, 3.32 moles of lithium carbonate. All right, last one coming up. All right, so number 10 says how many molecules are in 325 grams of dinitrogen pentoxide there, okay? So a couple things here. We see the word molecules, which is a representative particle, right? So every time we see atoms or molecules or formula units, something like that, we know that we're going to use Avogadro's number. So I'm just going to go, this is my trigger right there, right? So I know I need to use this number right here. So I'm going to go ahead and write that down just to remind myself that's a number I'm going to use. And that says 23, by the way. I'll write that one. Okay? Times 10 to the 23rd. All right? Now, I also see grams in my question, which also means I'm going to need to know my molar mass. Right? So, there's two numbers. This tells me right there, because I see grams and molecules in the same question, that tells me I'm going to have to do two conversions. In a case where I have to do that, I know that I have to go where first? All roads go through Moleville, right? So what I have to do then is figure out where am I starting and where do I want to end up. So the question says how many molecules are in 325 grams of dinitrogen pentoxide. Okay, so where am I starting? This is my given quantity. I'm starting in grams. So again, going to my flow chart, I'm going to go from grams to moles, and then from moles to representative particles. That's one of the things that molecules is, right? So I'm going to divide into moles, multiply out. All right. So before I can do that, though, I need to know my molar mass. I already know this number because that's the same number every time for that conversion. How wonderful is that, right? So I have N2O5. I already have the formula, right? So that's 2 nitrogen plus 5 oxygen. So it'll look like this. So 2 times 14.01 plus 5 times 16.00. And when I do that, I should get 108.02 grams per mole, right? And that is my molar mass. Okay. Now, I have all the numbers I need to do my calculation now. All right. So again, what's my given quantity? 325 grams. So that's my starting point. 325 grams over 1. Now I know I'm going to do 2 conversions, so I'm going to go ahead and make my table big enough to do that. All right. I'm going to go from grams to moles, then moles to molecules, right? That's simple, right? Now, what numbers do I put where? So, going into moles, which means I divide. So I'm going to divide by my molar mass, 1, and in 1 mole. Okay, so without moles, 2 molecules. If I'm going to use molecules, I need to use Avogadro's number. I'm out of moles, which means I multiply. All right. So 325 times 6.02 times 10 to the 23rd equals divided by 108.02. And when I get this, I should get 1.81 times 10 to the 24th, right? Molecules of N2O5. Okay, so again, walk back through the logic with you guys. So I need to know how many molecules I have. That's my automatic trigger to use Avogadro's number. Okay, I see grams, right? This is my given quantity because that's the number that I tell you. You start with this many grams. We want to know how many molecules that is. Okay, so this is going from grams to molecules, right? Because I see the gram symbol, right? I know that I have to figure out my molar mass. Okay, so I always find that before I even start the calculation. All right, it's just a good habit to get into. Now, if you started in moles and we're going to molecules, you didn't see grams or mass anywhere, you could probably forgo that step. You don't need to do that. But anytime you see mass or grams in these questions, you know you need to find the molar mass. All right, and that's not a hard thing to do. You just got to get your calculation done. Write that number off to the side somewhere. All right. So this tells me, because I see molecules and this in grams, I know I need to know molar mass. This tells me I have to do 2 conversions. All right, because I have to get into moles first. There's no really just direct conversion there. All right. Anyways, so we get into moles first, right? So I go 325 grams. My given quantity goes first. So I divide N by the molar mass. All right. Then I'm in moles now, so I can cross my grams off. Right. I'm in moles. I want to get to molecules. So moles goes bottom, molecules goes top. I multiply by Avogadro's number. Cross off my moles. Right? So 325 times that equals, divided by this, equals 1.81 times 10 to the 24th molecules of dinitrogen pentoxide. And that is beginning mole conversions, right? I'll get to gases later and we'll get to some other stuff later as well. But for now, keep doing it.